How to derive the system of algebraic equations. We have our piecewise polynomial approximation for the temperature. That's an assumed shape that's constructed element by element. And if we plug it into the differential equation, we won't get our algebraic equations. As we saw in the 1D case, the same thing applies in the 2D. So we go to the weighted integral form, where we multiply the differential equation with a weight and integrate over the entire domain. Now it's an area integral, so it becomes more complicated. And we know from the 1D discussion that we cannot satisfy this for any arbitrary weighting function because we've assumed a shape for t. So what we'll do is we'll satisfy it for a weighting function for which we pick a shape. So we pick a shape for t, element by element. We pick a shape for w, and then integrate over the domain. And then if we input, if we plug in the piecewise polynomial approximation for t and for w, out will pop the system of algebraic equations in nodal temperatures. And the key trick, if you remember, is to do integration by parts and transfer the second one of the derivatives to the weighting function. So you'll go to a first derivative in temperature, and you'll go to the first derivative in the weighting function. That works in 1D, that works in 2D also. The details get more complicated, but they are implemented in the ANSYS solver.